Okay, welcome everyone. I will just say a few quick words and then I'll hand it over to Jeff for the actual big presentation today and all things DuckDB and Airflow. As always, at the start of these webinars, we like to highlight a few things. We have some upcoming community meetups. So if you're in New York, DC, or Chicago and have time on those dates, check out our events page on astronomer.io. And then you can see details on how to join us and see a few astronomers in person and talk to other Airflow practitioners. And what we also want to highlight is content-wise. Exactly a week from now, we will have a full-length webinar on the easiest way to orchestrate your DBT workflows from Airflow. If you have heard the word Cosmos, it's already a small legend. This will be about the tool that is known as Cosmos. And the other thing we want to highlight, which is very relevant for what's Jeff going to talk about, is he wrote a Medium blog post that he's also going to reference during this talk, how to best use DuckDB with Apache Airflow. And lastly, the Airflow Summit. I don't know if you heard, but the call for papers was extended up until the 1st of May. So if you want to speak at the Airflow Summit, if you have an interesting use case, if you're doing something really cool with Airflow, please let us know. And then you can see some of us in Toronto. And yeah, with that, a couple of housekeeping notes. As Jeff said, turn your chat to everyone if you want to send a message to everyone. Otherwise, only Jeff and I can see it. And as always, this is recorded and the recording will be sent out to you afterwards. And with that, I'll stop sharing and I'll hand it over to Jeff, who's a Director of Field Engineering Machine Learning here at Astronomer. So the person to ask about all things machine learning in Airflow.
All righty. Thank you so much. My name is Jeff Fletcher. I do machine learning things at Astronomer. So I kind of focus somewhere in the middle between working on blog posts a lot, working with customers, focusing on trying to do presentations, and also working with our engineering teams and product development teams around all things machine learning focused. So I spend a lot of time working on ML workflows in Airflow and trying to understand how best that we can make machine learning work better in Airflow and with Astronomer as well. But today we're going to talk about DuckDB. Now, DuckDB came onto my radar. Also, I'm not going to have slides. This is one of those like live presentations. So at some point, I'm going to jump and I'm going to start showing you some code, and we're going to go through like, this is more live sort of DAG stuff than it is slides. So I just want to talk a little bit about kind of my DuckDB journey. So I saw DuckDB, like a few blog posts here and there, and I kind of didn't pay much attention to it because there have been a lot of these. There have been like so many of these different like database alternatives that have come up and about. So I thought, oh, it's yet another one. And I didn't look at it for a while, but then it started to gain more traction, and our Astro Python SDK team created a connector that meant that you can fairly easily use it inside Airflow now. So I started dabbling, and I had a look at taking one of my demo projects that I use for ML, which is doing the flight detection one, because it uses quite a lot of data. So it's a fairly big data set, and I wanted to see how well it worked. And I was using it with the integrations with the Python SDK and spending some time with it. I was struggling until I realized that I was using it wrong. And once I realized how best it can be used with Airflow, I started to get along with it. And then I realized it's actually very, very good. And if used correctly in an OLAP sense, so as in an analytics database, it is a very, very powerful tool. Now, what I realized, there's an article on Mother Duck written by one of the founders called Big Data is Dead. Now, I, prior to joining Astronomer, spent 5 years at Cloudera, and I still remember, I think it was probably about a year in, seeing a presentation from someone saying, the future of data engineering is Spark and Parquet, which were two words I hadn't heard up until that point. And they were right. I think that person then went on to go and join Databricks, and data engineering with Spark and Parquet is very much probably like one of the biggest use cases that we have. So there is a lot of people who understand and use Spark and Parquet together for data engineering processing. But the thesis that comes from the DuckDB people is data is not actually that big that you need to have lots and lots of machines doing this. And the commodity hardware that we used at the start, so when Hadoop first came out and you still had MapReduce, the machines that were available were small machines. So you had to use lots of them together in order to get that processing power. But cloud providers let you use very big machines now. And the process that DuckDB uses is Python threading to do the parallelism with inside one single process, so that you kind of do what Spark does inside one big monolithic machine rather than lots of small machines together. So it's kind of Spark without the JVM and without having to think about the underlying hardware on it. There is also a fairly new and interesting way that they compress the file. So the actual file that gets used, that gets created, is a combination of a vectorized store and a columnar store that makes it incredibly fast. And we'll have a look at that as we go. But DuckDB, when you're doing analytics and data engineering, kind of works in a similar way that you would use a Spark or Databricks cluster inside Airflow. But instead of having to connect to something external, you can do all of this inside the same environment that your Airflow is running. You can load files, you can do the data processing, and you can write them out again, because DuckDB does those particular things very well. So I am going to start by sharing my screen, desktop 1. And I want to move this to a different screen so I can see what's going on. Okay. So first thing is to reference this blog post. This covers a lot of what I'm going to be talking about now. I'm going to paste this in the chat quickly. So here we go. So that's that is that blog post. And a lot of the stuff is that I'm referencing here in the talk. You can actually go through in depth, and we go through the code. There is a repo that's attached to it, which is this repo here. And this, which I'm going to paste into the chat as well. This is the repo that goes with that blog post. Now, what this repo does is it sets up and gets running for you a couple of DAGs that use DuckDB for their processing. But I just want to take you through what you need to get set up and running at first. So here I'm inside my VS Code. I have a couple of things running on my machine. So the first is I have Docker. So if we go Docker PS, you'll see that there are some processes that are running. And I have the Astro CLI. So the two primary prerequisites to run anything is the Astro CLI, which is used to get a local instance of Airflow up and running, and some form of Docker engine. So if I go Astro dev, Astro dev, why is it doing that? DEV, yeah. Okay, Astro dev PS, okay. That's weird. That was very weird. Do you also see that? That was a strange thing to have happening. Let's try that again. Astro dev PS. Okay, cool. Seems to be working again. The process works with a whole bunch of files. The files come from the Transstats website. So Transstats website is the Bureau of Statistics, Transport Statistics. It's a US-based institution, and they have a website, pre-zip, which gives you zipped versions of flights from various years. I think this is the one that we're looking at, from various years as to whether the flight left, if it was canceled, a whole bunch of information about it. But we're not doing any analytics on this specifically. We're just using these files because they're nice big files and can get us with a reasonable amount of data in a reasonably short space of time. So there are a couple of things you need to do. In this repo is a script that will go and fetch the files for you. Annoyingly, the files are zipped, and inside the zip is a CSV file and also a README file. But because there's two files inside the zip, you can't use it as is. A lot of things will decompress a zip file. Pandas will do it, DuckDB will do it, but because there's two files inside here, it makes it slightly complicated. So we're going to decompress. So if you run the script, it will go and fetch the files. We're going to do the years 2018 to 2022. So just run the script some way that you have. It will fetch the files, it will decrypt, it will then There's also like a weird thing with the naming convention, so we fix it, but run the script, it goes and fetches everything for you. Once you have those files, you need to upload it to an S3 bucket somewhere. So I have my S3 bucket, which I use, which is my flight data, and you can see all of my CSV files have been uploaded there. So this is the path. JFML data has my flight data as well. And that gets me the files that I need, because we're going to go and edit some settings on this inside this DAG. The last thing you need to do is you need to specify some environment variables. So I cleverly changed this to not be my actual AWS S3 credentials, so that if you copy this, you can't use this information to mine Bitcoin on my account. But you need to, in the .env file, add these two things. I talk about this in the repo, but just kind of to take you through that process. So once you've done all of those things, you can then start up the process. So the start process is astro dev start, but this is already running, so it will tell me that the project is already running. But this brings up an Airflow instance with all of the other bits and pieces. So it brings up a scheduler, a web server, a triggerer, etc., and gets you to the Postgres backend, so that you are then able to run Airflow and interrogate and run a DAG. So my first DAG, if we have a look here, if we get to the DAGs, and also if you have any questions, just please feel free to pop them into the chat while I'm going. Anything you want to know or anything you're not sure of, I'm quite happy to take a pause and answer, because today is a little bit shorter than the usual ones. I have two DAGs. So the first one is just a test DAG. This test DAG is for me to run a couple of tests. So inside the first thing I wanted to see is how fast is DuckDB compared to loading something in pandas. So if we have a look at the code, let's go to test. This is the path to your bucket. So you need to go and just adjust this. And when you run it, it will go, the process is to go to your S3 bucket and fetch the files and then do the processing. So the first one is I go and fetch the file. You also just have to, actually, I must update my repo to say you've got to set your region correctly. So because I'm in Europe, that's the region I use. I think if you're in US East 1 or US West 1, that's the default region, but any other place you have to put in a region. Sometimes S3 regions are unnecessary. So I wasn't sure. The first time I ran this, it didn't need it. The second time it did. I'm not sure why. So I put the region in and it seems to work. When we select this, we can just select directly from the path. So DuckDB understands how to decompose or work out from the format of the URI that it's S3, and everything is built in with it. So you'll see I have a requirements file. These three here are specific to pandas when I do the pandas read. If you're just using DuckDB, this is the only thing you need. And if you want to add the Astro Python SDK, that you need also. But these additional ones are specific to pandas because these are required for pandas to read from an S3 bucket. The thing that took me a while to get my head around is I would do this process. I would then load the table. And there's a mechanism that you can say select star from. So if I don't do the create table as, it creates a Python relation, and that Python relation is always going to reload. So the first time I did this, I did it by going like my df equals, and I did that, and I just had a data frame. So then you can either process as a pandas data frame, or you can do the processing as my df becomes something that's accessible for you inside select statements. But every time you run, it would reload from the S3 bucket. If I do this as a create table statement, then it actually materializes it into memory so that I can do subsequent operations on it. So I wanted to see how fast is it between loading something into memory and doing a count on the number of rows between pandas. And it's about the same. If we have a look here, we can see the first one for the DuckDB one runs in around about 7 seconds. And the pandas one is about 8 seconds. So we're not really starting to see benefit yet, but once you do subsequent processing from here, so the first load is about the same amount of time. It's not a huge file. It's about 200 and something meg that's being loaded into memory and doing a count on the number of rows. If you start doing partitioning and sort of some strategies around improving performance, then it gets a little bit better. But in head-to-head on loading a single CSV, it's about the same. The next step or test that I wanted to do was converting a CSV file to a Parquet file. So here is the process that I'm working on in this step. So I'm going to take the flight CSV files and I'm going to convert them to Parquet. Now, the node that I'm running on, this is in AWS. It's a T3 extra large node. So if I go, is it LS CPU? So you can see that I've got 4 CPUs and the memory, so 3 minus H. So it's 4 CPU, 16 gig of memory. Kind of like standard laptop size. It's not a particularly big machine. Way bigger than we used to be able to get on cloud, but it's still kind of like the default entry level. Now, with these files, they're about 200 to 300 meg each for the CSV files. So in 1 year, you're doing about 2 gigs worth of like total CSV data that is then going to go into memory. What I found with this is the reading into memory is fine, but the writing to Parquet, there's a whole bunch of shuffling that happens. So I'm actually doing partition by. This is probably, this is where the spark and the utility of Parquet comes in. The partitioning is the thing that you use in data engineering to make things work faster. It's the one fundamental capability that Spark has that allows the parallelism to work very, very well. So if you know about that parallelism and you understand the nuance of getting a Parquet process to read and write faster, because it's kind of like from the Hive table partitioning strategies, we get the same here. This makes it run a lot quicker. When I ran this particular process of going from CSV to Parquet, if I ran it all in one go, it actually ran out of disk space. So it would do a whole bunch of temporary files and it started writing files everywhere and I ran out of disk. So my first thing was to then say, I need to do this on a by year basis and then run it only one at a time. So what I'm doing here, this max active task instances per DAG limits it. So this only one version of this task will run at a time. And I'll get to show you how you can actually see how that task is running in terms of load on the machine that it's on. And I'm then running this in parallel using the expand function. So the expand function here, so if we have a look, this is my flight CSV to Parquet. I basically take in a list and it automatically inside the DAG converts it into 5 concurrent processes. So if you have a look at those processes, you'll see there's the 5 mapped tasks that ran. But they only run one at a time because my little node that I have was not able to handle all of that data in one go. But because Airflow and DuckDB can work very nicely together, there are strategies that you can implement to make sure that things happen in a way that it makes sense within the size of the environment that you have. If I were to use a 5 times bigger machine, then I could take that max active task instances per DAG up to say 4 or 5, and then they would all run concurrently and we'd be fine. And by doing this, we by partitioning by year and by month, it means that each run is then partitioning. The year is already predetermined, and you are just then partitioning per month. So then goes and writes it out. And if you have a look, we can see when it actually writes it out into flights Parquet. So it creates year, 2008, month, and then you've got a bunch of Parquet files inside that. So that is DuckDB doing the write to those different processes so that it can run. The last test that I did was to just work with the Astro SDK. So this is fairly simple. It's using the Astro SDK as the back end for the for this process. So if I run raw SQL and I use the duck test connection, then I can do standard SQL processing, and I don't have to go and establish the connection. I don't have to do any of this necessary scaffolding to be able to use it. And you set that up by going to admin connections. And this is also in the repo documentation on setup, but you create this. So this is a capability that has been added by the Astronomer team to the Astro Python SDK. So if you have the DuckDB provider, you have this as a connection type. And it's fairly straightforward. You either have a local file or you don't have a local file. And we'll talk about the local file process in a moment. but that gets you to be able to do some of this testing. Now, one of the things about using a local file is, and this is very specific about the performance of DuckDB, only one process can talk to a file at a time. So if you have a second process that's trying to talk to that file at the same time and wants to write to it, you'll get a file lock error and it won't be able to run. So you'll see I have to do the same max active task instances per DAG is 1, which is an inefficient use of DuckDB. This is much better served by doing kind of updates or OLTP-like processing to then use the backend Postgres database or some kind of database that's better for it. But for analytics and for these types of heavy data processing tasks, you can then run, you can then do that using DuckDB. That's where DuckDB excels. Now, I talked about the problem with having a file and that the file is then, you can't write to it. If you want to do a create table and you also want to use the file for your connection, so you're then saying it's not an in-memory database, but it is a DuckDB process that is using a file. If I'm running 5 in parallel that are all talking to the same file, we'd have a problem. So because of the concurrency. So for this, I use import the, just use UUID, and I create a random file name. And that random file name is then what that DuckDB process is working with. So if I have 5 of them in parallel, each of them would go and talk to a temporary file that it's going to use for caching. And I found that even if I was running on a single one of these with the Parquet process, occasionally I would have it lock up because it would use up all the memory. So if you use a file, it is much more efficient and it starts to cache. So you don't actually ever run out of that, run out of processing power. And I will actually run this DAG after we've had a look at the second DAG, just so we can talk through that process and show you some strategies of how to manage it. But that is what we're showing for the first, the test DAG. So the test DAG does a whole bunch of testing. So if I go back to my DAGs, my first DAG, it just tests things. So it sees how fast it is, how fast DuckDB is compared to pandas. We do a CSV to Parquet with a couple of strategies to help it work in a small data environment. The interesting thing about this is there's no ways pandas can use data at the size that you start to process. So if I try and get pandas to open all 12 of those CSV files, it crashes. So anything I think that's above about I think it's about 2 gig in memory for pandas isn't going to work and it's going to crash. There is polars and there are other strategies for this, but DuckDB just became something that I found worked really well from a speed perspective. Now, the second DAG is where the actual process comes in. So let's go back to our DAGs. This is the process that I want to follow. And I talk about this quite in depth in the blog post, but I just want to take you through the diagram for it. So what I'm doing is I'm fetching the Parquet files. You want to go and fetch your files remotely, and you want to put them onto the local file system because an S3 pull is takes quite a long time. So I get all of that data, and then I create a DuckDB engine file or DuckDB version of that file on the local file system. Then I generate the queries that I want to generate, and then I run them all in parallel. And there's a specific trick that I'm going to use, but I pull it locally. I then use the temporary file system. So I used /temp. If you're on Kubernetes, you probably have to use a persistent volume, but you want something that is temporary that you can then go and delete when you're not no longer needing it. And each of my parallel processes references that file that I fetched remotely, does the querying, collates the data, and then stores it again remotely. So we're kind of doing similar things to what we would be doing with Spark, where we would be caching with a persist, but that is starting to be cached locally. So you fetch from the remote, you cache locally, you process, you then collate, and you push it back again. So that's the process that we're following. And if I go to the file, process file. So the first step is to go and fetch the Parquet file. So I have all of these Parquet files and I create a table, but I specify a local path instance. So I'm going to say everything is going to go into /temp/all flights. Now I want to do the parallel processing. So first I load a single process, as a single task that loads that file that I grabbed from the previous step. So this is going to write it out and return the path. Then I take that path and I want to say, I want to find the top destination cities from that data set, and I want to order them by the top 10. So I want to take the top 10 cities, the flight destinations inside all of the flight data that I have from 2018 to 2022. Then we want to do the filter, and we want to filter and come down to the count. So how many flights went to each of those top destinations? Now, there's probably better ways of doing this from a SQL perspective, but this is to show the process of specifying read-only as true. When you do that, you don't have the concurrency problem with DuckDB. More than one process can read from a file. So I can spawn as many processes as I want because they don't clash with each other. They read and they are able to do analytics on it. The one limitation here is you can't create new tables, but you can do very complex SQL queries and you can do lots of them in parallel. So I would think that the utility for this is not just in complex data engineering, but also for something like machine learning, where you're then going and extracting specific sets of features from a data set and then running your model training or different hyperparameters. You can get the data into memory incredibly quickly this way, because it is all looking at the same file. It's all in a local file system, and it's all very, very fast. And I'll show you kind of the speed differential that you get. Then we want to take these top cities. So the return from each one is, this is inside an at task. We're returning a dictionary, and Airflow is configured to understand that this is XCOMs, but is actually ingested in the next task as an actual dictionary. So it goes into a dictionary, and that's what I go and write back out to my process. So I load the Parquets, I put them into a single file in the local file system. I then spawn multiple processes or multiple tasks. Each of those load this data into memory, but it can do this very, very quickly. So let's go and have a look at how we run this process. I'm going to run this DAG again. Of course, doing a live DAG demo is always daunting, but let's have a look and make sure it runs. So it's going to go and fetch. So those files are going to go and be fetched. Now, because I did a create or replace, the table already exists, so it doesn't have to do this. You could just say create table, and then it would force it through. So if we have a look, my first line is create table if not exists. But because it already exists, we're not going to overwrite it, so it makes it a little bit faster. But now each of these, this is the filter, so this is running. So this runs, and it took to do the filter, it ran in details all of the time. 0 seconds, so it's very quick, like basically milliseconds is how long it took. Then we're doing the filtering. So now I'm doing 10 processes in parallel. So we have 10 map tasks. Each of those is scanning 31 million rows to count, and it's specific because it is a where clause in the count. So we want to say count from where destination city is X. So it's a little bit more complex than just a count number of rows, because which means that there's a table scan. There is a table scan, but it's a column scan because we're specifically specifying a destination, and the vectorized / columnar store of DuckDB makes this very fast. So we did 10 of those. That's 300 million rows, but it took 4 seconds to do all of it because I can do it in parallel. And the output from all of these, as you can see, if I have a look at my XCOM, is returning that value. I then collate all of these together. Let's go back here. I collate all of these together, and then that's what I write back out. So this gives me my collated list of top 10 cities. That's what I collate, and that's what I push back out. The main understanding that I got from working through this is that if your queries are not needing to create new tables, or you can do a query that you can write out to Parquet, you can do lots of these in parallel against the same database file, because you can set it into read-only mode. So this makes things a lot quicker in terms of the overall processing. So that's the example use case. That, I think, is the primary goal, is to say, focus on using Parquet and using parallelism with the Airflow expand command that lets you run multiple queries that aren't necessarily creating new tables in parallel. If you do need to create new tables, then you can use the same strategy that I used here for the test DAGs by creating a randomly named local database file. These are often in the temporary folder transitory. If you're running inside Docker or inside Kubernetes, /temp often gets deleted after a process has run, so you don't use up all of your disk space. The one last thing I wanted to show was when I run the first DAG, so if we go back to the DAGs, and you want to see, it took me a little while to work out why are things crashing. And it's just a quick show on how to debug some of these things when they're running inside the Astro CLI. So if I start another process, these processes will start up. So the first one's going to be the the 2 CSV loads. But when you get to the flight CSV to Parquet, how I worked out that in order to get this to complete was minimizing the number of concurrent runs, was I would actually go in and have a look to see how it was running inside that the process. So let's just wait for it to complete. This one is running. You know, they usually use sort of 7 or 8 seconds, and they usually go quite quick. Okay, so now we're onto here. So you can see it's map tasks. So because I specify a max number, it will run one at a time, and it is using the expand to do all 5 years. So now this task is running. In here, one of the features that we have that's part of the CLI, so let's just go clear and clear, is the ability to connect using a Docker execute command into one of the running processes. So if we go astro dev bash, that gets me into the scheduler. You can also go, if we go exit, astro dev bash -h, it'll tell you there are different things you can connect to. So -w connects you to the web server. So if you want to get access to the actual process that's running, but we just need this one. And we can have a look by running top. So what top is now inside the container, it will show you that there is a task that's running. The other thing that's useful to do, if I do this here, astro dev bash, and I can go watch -n1 ls -alh/temp. There we go. So you can see that this file, this is the value here that's increasing. So this is the temporary file that we created. So this is the file that we create here. If there are multiple of them, so if you actually set this to 2, then you would see 2 files going up. You can see the size of the file, and it kind of gives you a sense of how much data is being used. And then this shows you the task and task utilization. So we're up to 45% of the memory of this machine, and it's running, how long has it been running for? Been running for a minute. And this one takes, to do that conversion, it's around 6-7 minutes to run. So if you want to speed it up, you can go through the process of just using bigger nodes, increasing the number of concurrent concurrent processes. So this, we're already at like 53, it gets to about 61% in terms of the peak when it runs. And so if I run 2 of them at the same time, then I run out of memory. Interestingly, it doesn't crash. It just locks me out of the machine. And then I have to come back like half an hour later to try and use it. And then if I'm trying to do other things and like edit code and whatnot, it's locked up. So it doesn't crash. It does crash if I run, try and do this in one go with Parquet. It will try and write it all out, because the temporary files that start to spool and go as it does the Parquet write ends up using up all of the disk space. So by just managing things from that basis, things go a little bit quicker. Where is the DuckDB install in this demo? The DuckDB install in this demo is here. So in the requirements.txt file, I'm adding DuckDB as a requirement to Python. You don't install an application, it's a library. It works very similar to the way SQLite works. And I instantiate it by going duckdb.connect. So once I've done that, DuckDB is installed and running. It's as simple as pip install duckdb, start your Python process, import duckdb, duckdb.connect, and you have DuckDB running. You don't install, it's not an application in the same way that you would be running like MySQL or Postgres. It is an in-memory database processing tool that you can run inside Python. So you don't have to do anything else to get it to work. Alrighty, so that was what I wanted to talk through. We got some time. If there's any questions or anything else that I can help you with, I know that Tamara has some other things that she wanted to talk about as well.
Yeah, thank you so much for going through all that. That was pretty amazing, especially hearing your thought process and the story of how this repo was built is super useful. Also for someone, I ran into the same issue, first using DuckDB with Expand and the parallelism and how you solve that. That's super valuable, I think, for everyone to know. I'm going to give everyone a minute to think about additional questions. You're caught up so far, I think.
Mm-hmm.
But I just wanted to share one last slide for everyone. Yeah, there was a question at the start, where can I learn more about Airflow? You can learn it on our resources on the Learn page. You can also go to the Academy if you want a full-length free Airflow course. And what we do for people who attend our lives and webinars, if you use this discount code, I can also paste it in the chat, then you get a free try at the exam. And we have one question in the Q&A.
Yes, I see that.
Yeah.
So the question is DuckDB good for OLTP? No. So short answer is no. Long answer is no. So it's a concurrency problem, right? It's fundamentally around multiple things accessing it. So OLTP is transactional. You want to make sure that whatever connects to it will be allowed to connect and the transaction will go through. It is not configured for that. It's an OLAP database. So it's about analytics and it's about doing very complex SQL on like large amounts of data quickly, more than it is about many transactions or making sure that you necessarily close a transaction. For OLTP, Snowflake or something like that is more suitable.
Yeah, great question and great answer. Okay, are there any more questions? I think that seems to be it.
Okay.
Thank you so much again for going through all of that and for creating all of the demo and the repo. As I said at the start, but for the people who joined in the meantime, the recording and the repository will be sent out to you afterwards to everyone who registered, so you can go through it on your own time. Yeah, and with that, hope to see you. There's one more question that came in. Very specific. Have you compared DuckDB with Ray.io?
Yes. So I have. I've actually done a fair amount of work on both. Ray is like Ray still requires a server. So Ray has their own concept of data frames, and Ray uses, like we're getting into the weeds now, but for its data storage uses something called Plasma. So what Ray is doing is trying to keep a data frame in memory, and you can pass it from step to step and similar processes, but you still have to instantiate Ray and then start a data frame. So to run Ray in a similar way inside Airflow is you can. So I've actually there is a Ray Airflow provider that allows you to start a separated Ray service and then kind of move your Airflow tasks along. Ray is more optimized for like very specific machine learning type workflows that I would think are less about data engineering and more about transformations and extractions that you would do. So like if I need to do a convolution on a data set for a step inside a neural network, Ray is very good at that, but it requires a service. So in order for Airflow to use Ray, you actually have to bring up a Ray process, and then there's an interaction between the two. So it's a little bit more complex. I put Ray more like a version of Spark that's optimized for machine learning than it is for pure data engineering, versus DuckDB, which is something that you can then separate from it. It doesn't need, it's its own in-memory processing engine in Python. It doesn't need a service to run.
Yeah, thanks for the question and the in the weeds, in depth answer. I think that's the theme for this live and this evening. Very in depth. And yeah, with that, I hope everyone has a great rest of the week. Great evening, day, wherever you are, and see you soon, hopefully.
Thank you.
Bye.
Bye-bye.